Cost perspective, you only pay per second and only when your application serves requests. Copilot. Choose DynamoDB from the list of the storage types. His is our table name. Counter is the partition key. Now, any application will belong to an environment such as staging, test, or production. Let's create an environment with Copilot so that we can deploy our application into. Let's use test as our environment. This will take a while. Our environment is ready to deploy. Let's deploy this test environment. Now the environment is deployed. Let's deploy the application to the environment using Copilot deploy command. What's happening from now is Copilot will go and create a new app runner service, a new Elastic Container Registry. It will build the Docker file locally and push the container into the ECR repository and use this container for AWS App Runner. Once the deploy is finished, Copilot will return a service URL so that you can access our application. Now our application is deployed and accessible from this URL. Let's try using curl command to test it out. As you can see, the application is now able to return a number of requests it has received. Now let's check out the application in AWS console. We can see that the application is now shown use this container for AWS app about the DynamoDB. Let's have a look at our table and see the data recorded. Receive more requests than this number. Please spin up a new one depending on the environment it is running, and we would like to show you how it can be done with Copilot and App Runner. Auto-scaling configuration. We probably want smaller CPU and memory required for auto-scaling configuration. The CPU, 20 concurrent requests per instance, and max number of instances is 20. Now let's update the Copilot service manifest file to use these auto-scaling configurations. The service manifest holds all the configuration related to a service deployed by Copilot. Let's comment out the CPU, memory, and then override them per environment. By using the environments, we can override the configuration for each environment. Let's override for test and production environment. Let's apply the auto-scaling configuration we create to count attributes. The count attribute is used for auto-scaling configuration. In this case, we can see that the new configuration is applied. Great, we already deployed to test and production. Let's save and deploy. Let's deploy using service deploy. We want to deploy to test environment first. Let's environment as expected access. You can have a I realize this intuitive user experience. To create a pipeline, we can use Copilot pipeline init. You would need to specify what environment you want the pipeline to deploy to. Next step, you would need to push the chain to your repository and then run the Copilot pipeline deploy. In this step, please make sure you go to the URL highlighted here to update the connection to your repository. This is to make sure that the code pipeline has the sufficient permission to pull the code from GitHub. We need to select the pending connection and then click on Update Pending Connection. Select your GitHub username and hit on Connect. That's all now. As we can see here, the code pipeline CI/CD is now up and running. Going inside the pipeline, we can see the pipeline has 3 stages: pull the source code, build, and deploy the test environment. Let's have a quick look into the pipeline. Now, let's try to make a change and get the CI/CD to deploy the change to our test environment automatically. The change is here basically to print out a message to show what environment this application is running on. I'm using a special environment variable injected by Copilot to show the environment name. Let's commit the change and then push it out to the repository. Let's jump into the AWS console and see if a build has started. Awesome, a new build has started. Let's wait for it to finish. Let's check the build status. Looks like it's successfully deployed to our test environment now. For attending the session, we hope you enjoyed